Hey guys, here we go. This is Unit 1, Video 2, precise graphs of parabolic functions. So we're going to start out with my first example here. Now, I used function notation here. I said f of x equals, now just a reminder, you went over this in Algebra 1, but f of x, function of x is just a fancy way to say y equals. Just a fancy way to do that. So you'll see me use function notation sometimes. Look, here's my second example. It's got a y in it. But here we go. Let me get rid of all that noise so it's not in the way. Whoop. And what I'm going to show you guys is different methods to get to the same result. I always teach this way. The more you know, the easier your job is because you can make a choice what is the easiest way to get somewhere. I have 5 examples to go through. I picked these 5 because they all illustrate one or another skill that will make your job easier. So, this first example is in vertex form. Vertex form is the parent function style format. So right off the bat, I know if it's in this format, I'm going to go opposite, same. I have a vertex. It's right there. My vertex is 2, 3. I have a coordinate system. I'm going to plot the point, 2, 3. So I go 2 to the right, up 3. There's my vertex. I am going to draw a precise graph, not a rough sketch. I want this thing to be more accurate. To be more accurate, I use actual numerical values that are going to help me out. Oh, by the way, you'll need a calculator for this one. It doesn't have to be a graphing calculator, but I do want you to get one. You're going to need it in next lesson. But here we go. I found the vertex. Let's find the y-intercept. Now, the y-intercept, remember, this is just a fancy way to say y equals. The y-intercept of any graph is found when you plug in x equals 0. If I plug a 0 in for this thing, I will get y equals negative, well, parentheses, nothing minus 2 squared plus 3. Order of operations, I do this part first. The parentheses is negative 2 squared. So negative 2 times itself, I'm going to get 4. But then I'm going to negate that 4 plus 3. So what comes out? My y-intercept is at negative 1. Now technically it's at 0, negative 1. But if you don't write it as a point, I'm not going to take points away from you. That's good enough for me. You know where the y-intercept is. So the y-intercept is now on my graph. But here's the thing. We've got to find some x-intercepts. Now, this particular problem, if I want to find an x-intercept, I set y equal to 0. Or in this case, they started with f of x, so I would say 0 equals negative parentheses x minus 2 squared plus 3. I'm setting the entire function equal to 0. That is how I find x-intercepts. So if it's set equal to 0, there's a couple different ways I could go. I could do it this way. I could take this chunk here and FOIL it, because this says squared. So it would mean x minus 2 times x minus 2. I could do that. Then I'd have to negate all that information, and then I'd have to add 3 to it. That's just to set it equal to 0, and that is what I'm trying to say is not the easiest way to go. That would not be the easy way to go in this situation. In this situation, I want you to do something called cheerleading. Well, what do you mean by cheerleading? Here's what I mean. Let's look at the original. 0 equals negative x minus 2 squared plus 3. I want you to get the squared information by itself. So I'm going to move 3 to the other side. I'm going to take it away. So now I have negative 3 equals negative x minus 2 squared. Well, this is just a negative 1. That's all that really means. That's what it represents. So I'm going to divide both sides by negative 1. And if I do that, I get negative 3 divided by negative 1. That's 3. What's it equal? It equals x minus 2 squared. This is why I call them cheerlead equations. What do cheerleaders do? They root. If you take the square root of x minus 2 squared, if you take the square root of x minus 2 squared, you get x minus 2. If you take the square root of 3, you get the square root of 3. But here's the thing. When you are solving a quadratic, power of 2, you're supposed to get two answers. One is based on the positive version, one is based on the negative version. Let's move the 2 over. If I add 2 to the other side, if I move that 2 over, I will then get x equals 2 plus or minus rad 3. Those are my x-intercepts. So I would say, hey, here's my x-intercepts. But where does that go on my x-axis? Let's look at this. Where does that go on my x-axis? Well, let me get that big red circle out of the way for a second. And I'm going to go back to black. Ooh, Amy Winehouse. Here we go. I am going to punch in on my calculator off camera here. What is 2 plus the square root of 3? See, here's what I'm going to ask you to do. I'm going to say, you got to convert this to a decimal for me. 2 plus root 3 turned out to be 3.7320508808. I'm just going to say round it to the nearest tenth. We're going to call it 3.7. 2 minus the square root of 3. On my calculator, I am punching in 2 minus the square root of 3, which gives me 0.2679 blah, blah, blah. I'm going to call it 0.3. So, now I can plot that. 0.3, that lives about right here on my x-axis. I'm over here on my graph again. Then 1, 2, 3.7-ish. There's my other guy. So if I were to connect these dots to draw a more precise graph, that's what I would get. And that's what I'm asking you guys to do on this assignment. Now, yeah, my graph looks a little wonky. I should have put the vertex over a little bit to the right. But I need you to be able to come up with all of these numerical values. Now, let's go back. Vertex form is my first example. Vertex form is written parent function style. So the benefit of that is I know my vertex right away. Also, finding my y-intercept is not difficult to do. Remember, right here, I found my y-intercept. When you plug in x equals 0, you get a y-intercept out of that. Then, I set the whole thing equal to 0. That's how I found my x-intercepts. Now, don't worry. I outlined all this information for you, but let's compare that to something called standard form. Here is a standard form problem, and I'm going to do this one and graph it, make it precise. This is my second example. Then I'm going to show you my outline down here. Okay, I don't want to show it to you yet, but I want you to know it's organized. So here we go. This guy right here, we've seen these in Algebra 1. Standard form means this guy, where it's y equals ax squared plus bx plus c. That's not vertex form, that's called standard form. So when I'm doing this kind, there's a couple benefits. Hey, I plug in x equals 0. If I put a 0 right here and a 0 right here, that means this is going to end up canceling out. There's nothing left here because I get nothing squared. Minus 2 times nothing minus 4. Heck, my y-intercept is negative 4. I could call it 0, negative 4. It doesn't matter to me. But boom, it's on my graph already. I am right there. Y-intercept is on my graph. But x-intercepts, well, how do I find an x-intercept? No matter what the function is, you set it equal to 0 to find x-intercepts. Now, this guy right here is not a cheerleader. I cannot do this. Oh my gosh. I gave you guys some practice problems in the summer packet. Don't be doing this to me. This is not a legal move at all. That's, ow. That is never good. That is so not right. Don't do that. Ouch. But, whoops. What you can do is say, hey, my A value is 1, my B value is negative 2, my C value is negative 4. I could use something called the quadratic formula. So the quadratic formula, just in case you forgot, remember it's x equals negative b plus or minus the square root of whatever b squared minus 4ac turns out to be. Take that whole thing and divide it by 2a. Quadratic formula, because we're in standard form. When we see this kind of setup, that's what we're going to use probably. Now, I would do negative b, so a negative b is 2, plus or minus square root of b squared. So if I square negative 2, I get 4. I go minus 4 times a times c all over 2 times a. And then what do I get in here? I get myself a 20, it looks like. That's number 20. So I get 2 plus or minus square root of 20 over 2. But this is very impolite mathematics. I am a big fan of politeness. What you would do is you would simplify this radical and say, hey, I know that 4 times 5 is the same as 20, so I can take the square root of 4, that's 2. So I get this, and if and only if all three outside numbers have something in common, only if that happens do you get to reduce this or cancel this down and make this a much easier, smaller number, which would be, come on, 1 plus or minus rad 5. My x-intercepts are 1 plus or minus rad 5. They are. But you know what? If I'm going to put those on a graph, heck, I don't know what the square root of 5 is. I don't have it memorized. It's not in my head. So I grab my calculator. Once again, 1 plus the square root of 5 gives me 3.236. So I'm just going to call it 3.2-ish. So 3.2. I could put that on my graph. That's about where 3.2 lives. And then, what's 1 minus rad 5? 1 minus rad 5 is negative 1.2-ish. Negative 1.2-ish. So I go over here and I go negative 1.2-ish. Okay, great. So I have an x-intercept based on this. I have another x-intercept over here based on that. I had to convert them to decimal so I'd have an approximation where they live on the x-axis. This is called an exact value. This is an approximation. We live in a lot of exact value stuff in mathematics, but sometimes we have to approximate it so we can graph it. But you'll notice there's one thing I totally skipped over. I don't have a vertex for this graph yet. I don't. Well, my vertex is not going to be easy to find because I'm not in vertex form. Let me scroll for a second. Vertex form, the big benefit of it is you know the vertex right away. But not all is not lost. Look, if I want to find the vertex of this thing, I use a trick called negative b over 2a. This guy is the x-coordinate of my vertex. It's also known as an axis of symmetry. I'm just going to abbreviate, axis of symmetry. So I do negative b, so that's a negative negative 2, over 2a, and that's 2 times 1. That turns out to be, well, 2 wrongs make a right. There's 2 divided by 2 times 1. 2. So I get x equals 1. That's my x-coordinate for my vertex. Well, how do I find the y-coordinate for my vertex? I plug it back into the original. So I go, hey, original problem. I saw that you had y equals x squared. Well, I'm going to say instead of x squared, how about 1 squared? Minus 2 times x. Well, let's just call it 1. Take away 4 was the end of it. See, all I'm doing is I'm taking this guy right here and I'm replacing the x with a 1. And I get order of operations. 1 take away 2 take away 4. I get negative 5 as a result. Negative 5 as a result. Now, if you happen to have a graphing calculator on you, you punch it in exactly how I wrote it here with the parentheses, etc., and it will do the order of operations for you. No fooling, it is a fact, Jack, even if your name's not Jack. So here we go. I got a vertex out of that thing. It's 1, negative 5. So x is 1, y is negative 5. And then I go, wait a minute, there's my vertex. I got a y-intercept. I got 2 x-intercepts. I can make a pretty darn decent-looking sketch of this parabolic function. Oh, this was way better than my first one. That's pretty. And there's all my info. There's all my desired information. There's a vertex. There's a y-intercept. There's my x-intercept information. So let me show you this assignment, just so you, or this set of rules that I'm outlined for you. It says precise graphs of parabolas. So you pause this, you take a picture of it, you've got it with you. If you want, you can print it out later or something, but you'll notice I broke it into 2 categories. If you have a format like this, and you want to find the vertex, for this, use the axis of symmetry method. Use this formula, plug x, the x value you found, into the original function to find y, then you got a vertex. Or, you'll notice my second arrow over here, or they give you what's called HK form. There's names for all this junk. Y equals x minus h squared plus k, parent function style format. Now, if they do that, you just go, oh, set that equal to 0 in my mind, take whatever that is, there's my vertex. So when you need to find a vertex, depends on which format they give you originally. Do the easiest possible way. Now, whenever you want to find a y-intercept, no matter which format you're in, when you want to find a y-intercept, what do? You set x equal to 0. You get y. How do you find x-intercepts? You set y equal to 0, and you solve for x. There are 3 methods for finding that x stuff. I already showed you this one, cheerleading. How do I know I'm going to cheerlead? Because I've got x minus stuff squared plus stuff equals 0. That's cheerlead style for sure. When it's like my second example, I had to use quadratic formula. But a lot of people forget factoring is a very efficient way to solve a quadratic equation. So let's look at an example that's going to use factoring. And here it is. It's down here. Let's see. I think, example 3. Now, I put it conveniently, this one, right next to your assignment. So it says Unit 1, Video 2. That's the name of this assignment. What does it say for you to do? It says, accurately graph each parabola using any technique you want. So when I say any technique, I mean do the easiest thing possible, depending on the information I give you. Now look, there's 8 questions here. And just like I told you before, this one has the answer key. It's right here. There's the answer key. Question 1, 2, 3, 4, 5, 6, 7, 8. But there's one thing I did not do for you. I didn't draw all the graphs. I didn't want to make this video an hour long. So there's, for problem number 1, there's a vertex, there's a y-intercept, there's x-intercepts. They're converted to decimal form. You could put those dots together and sketch it. But if you have different dots than me, you're going to have some problems. So please check your answers. Now you'll also notice, like problem number 7 here, the answer key, I used fractions because I thought it was more convenient. And number 8, I used decimals because you know what? I thought it was more convenient. As long as you're right, I don't care. There are some times when I will care, but we haven't gotten that far yet, so I'll let you know when I do. Anyway, there's the answer key for these 8 questions. But I have more examples because you're going to run into different things. So let's talk about those. Come on, come on. Here we go. Is this in vertex form or in standard form? It's in standard form. So I know right away if I plug in, or if I do x equals negative b over 2a, my b value is negative 4, so I get a double negative. Over 2a, my a value is negative 1. So I end up with 4 divided by negative 2, or 4 over negative 2. That gives me x equals negative 2. That is the x-coordinate of my vertex. So I'd say x-coordinate negative 2. Now, I know if I punch this in on a graphing calculator, and I'm really cautious with this dude right here, because this says negate whatever x is after you square it, because order of operations. Minus 4 times whatever x is, plus 5. If I punch that into my calculator correctly, without making any kind of goofy error, it is going to kick out the number 9, because it should. Order of operations, negative 2 squared, that's 4. Then you make it negative. Then negative 4 times negative 2, that's 8. 8 plus 5, that is 13. But I'm going to take away 4 from that, and there's my 9. So the vertex is at negative 2, 9. If I plug in x equals 0, because remember, you want to find a y-intercept, you plug in x equals 0. Boom. If I plug in x equals 0, easy peasy, because negative nothing squared minus 4 times nothing plus 5 is 5. Do you guys remember that the c value, not the a value, not the b value, but the c value is the same as the y-intercept? So I have a vertex, I surely do. I have a y-intercept now, I surely do. It is 5, or you could call it 0, 5. I'm okay with either way. So let's start filling in some blanks here. What did I have? Vertex. Here, I've made this up already. I got vertex at negative 2, 9. I got y-intercept at 5, or 0, 5. X-intercepts. Now, here's where I wanted to show you this example, because factoring is not your enemy. It's not a bad guy. Remember, you want to find x-intercepts. I can set x equal to 0, solve for y. Factoring is one of the ways I can find those answers. Check this out. See this guy right here? I'm going to do it right here. If I say negative x squared minus 4x plus 5, I'm going to set the y value equal to 0. What you're doing is you're solving a quadratic equation, and don't just jump right on the quadratic formula right away. If it's an equation, you set it equal to 0, you can solve it any way you want. But here's one thing I'm going to say as a real good hint. Never solve anything with a negative high power. If this guy is your highest powered thing, x squared, and it's negative, You don't have to live with that. You can move all of the information to the other side of the equal sign mentally. You don't have to do it physically. You can just do it mentally. If I move that x squared over, that negative x squared, it'll become positive x squared. If I move that negative 4x over to the other side, it becomes positive 4x. If I move that 5 over, it's negative 5. Everything is on the other side now. There's nothing left over here. Why would I do that? Because it makes factoring this so easy now. I want to do x times x. That'll give me an x squared. 5, heck, I could say that's 5 times 1. It would have to be a positive 5 and a negative 1 to make it factor correctly. So what are my x-intercepts when I set them equal to 0? Negative 5 and positive 1. There they are. I don't have to use a lot of fanciness for this. So I have x-intercepts. They're at negative 5. Whoop, come on. Negative 5 and 1. Let's put some dots on this thing. So I already see a vertex at negative 2, 9. Okay, now here's the deal. Negative 2, 9. See how I already drew my coordinate system out? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I have negative 2, 9. So here's something I'll show you in the next example. There's my vertex. And remember, that might look really high up there, but doesn't this graph open downward? I think it does. My y-intercept is at 5. 1, 2, 3, 4, 5. And then I got x-intercept at 1 and at 1, 2, 3, 4, negative 5. What? Look at how special this is looking. Oops, I couldn't have missed that dot. I'll just make that dot big. There. Anyway, when I say precise graphs, I know these are not the most beautiful graphs you've ever seen them in your life, but that just means you are actually able to provide me with all this information so that the graph looks decent. Okay, and I know you know how to calculate stuff. Once again, you're going to be posed with these 8 questions. You can check your answers as you go through and see what they are. You can connect those dots and draw 8 graphs for me. That assignment will be due, and then you'll turn it in. Let's take a look, though, because you might be going, well, I'm good. I can start working on this. All right, go for it. But I always try to look out for, yeah, what if this happens to you? What if that happens to you? So I have 2 more to go through because you might see one that looks like this. I'm going to just use function notation for a second. This is example 4. What if they give me something that looks like this? And they say, make a precise graph, find all this stuff. Well, this is one of those sneaky ones where you might go the wrong way and end up doing extra work that you don't need to do. If I want to find the vertex, first off, this is not in vertex form. So I would do shortcut, negative b over 2a. I'd get 3/2. Or I could say 1.5, whatever you want to do. It doesn't matter to me. On this one, I'd probably say let's use decimal. But then I'd have to plug it in, so it'd be 2 times 1.5 squared minus 3 times 1.5. And then, thankfully for me, I have a calculator right here, and I am going to punch this thing into the calculator, knowing that if I punch it in correctly, the calculator will do the order of operations for me, and it will give me the exact answer that I'm looking for. And it says, when I do that, that I got out 0. Let's see, I don't think that's right. Let me make sure I didn't hit finger flub something here. So I'm going 2. 5 to the second minus 3 times 1.5. I'm getting 0, so I guess I'm going to assume it's 0. Let's see, though, because the thing that's making me wonder here, here we go. 1.5x, y equals 0. My y-intercept is at 0. So that can't be right. Why is that not correct? So let's make sure. Oh, do you guys see what I did wrong? I see what I did wrong. It's not 1.5 at all. It is negative b over 2a. See, it's the subtle little things that you mess up on sometimes that you go, what? Why is that not right? Well, be careful. But now I got 0.75. Well, that's not right. That didn't work out. Oops. But let's see what happens. My vertex is at 0.75, comma. Now I punch this thing in. Minus 3. I get negative 1.125. Negative 1.125. And that makes sense to me. So let's go over here. I'm going to get rid of this. Whoa, I got rid of the whole thing. Let's try and put this part back. Hey, that was cool. All right, so I got x is 0.75. Y is negative 1.75. And guess what? I'm just going to guesstimate. That looks about right where it would be. There's my vertex. Now, my y-intercept is at 0. Because if I plug in x equals 0, everything vanishes. And that's how I knew this before right here was so wrong. Because you can't have that wouldn't have worked out. How am I going to draw this graph if I have a vertex on the same level as a y-intercept? Doesn't happen ever. So, let's set this baby equal to 0. This was the part I wanted to get to anyway. This is the reason why I made up this example. If I set it equal to 0, do not always assume that you should try and cheerlead something or you should try and quadratic formula. Number one, if you were to move the 3x over and do this, you have made up your own mathematics. That is totally illegal and cannot be done. Bad news. The other thing is, I could go straight for quadratic formula. Some people are like, I'm going to do quadratic formula for everything. That will come to bite you later. So try not to do that. Let's talk about factoring, because the first rule in factoring anything is take out the GCF. What do they have in common? X. If I take x out, I would then have 2x minus 3 left over. Set each piece equal to 0. What would I have to plug in here to make it say 0? 0. When will 2x minus 3 equal 0? When will that happen? Well, move the 3 over, divide by 2. Move the 3 over, divide by 2. Oh, when x is 3/2. Or you could say 1.5. 1.5. Oh, well, guess what? There's my graph. Now, this example here, I know I messed up at the beginning because I was going fast and I didn't do my negative b over 2a like I should have over here. But anyway, I'm not going to restart this whole thing because I get one shot at recording this. Let's see. Do you see the question that I made up for you guys to try that is similar but not the same? I have one question here that is similar to all my examples, if you know what I mean. Now, there's one on this sheet that I haven't shown you yet that I want to make sure you do not mess up, because this is where you are trying to be polite with your mathematics always, and it's problem number 4. Now, you might look at number 4 and say, that doesn't look that difficult. Problem number 4 isn't that difficult if I ask you what the vertex is. Heck, it's really not that difficult if I say, what is the y-intercept for number 4? Where it gets difficult is the x-intercept. Let me explain. I have one last problem, but I'm not going to go through the whole thing. My last problem that I want to show you guys, I am not going to go through the whole graph, the whole thing, and whatsoever. Here's my last example. Example 5, I have y equals 3 parentheses x plus 1 to the second minus 5. Now, if I plug in x equals 0, I get a y-intercept at -2. If I asked you what the vertex is, you should say -1, -5. Vertex is easy. Here's where you can mess up. To find x-intercepts, okay, remember, x-intercepts, you find it by setting y equal to 0. So if I set this entire thing, equal to 0, it's a cheerleader. This is a cheerleader. Get the squared quantity by itself. How am I going to do that? Add 5. If I add 5, I would now have this. Divide by 3. I would then have x plus 1 squared equals 5/3. And this is why we call them cheerleading equations, because now I do what a cheerleader does best, which is root. They root for things. I get x plus 1 equals plus or minus, because there's always 2 answers to a quadratic, plus or minus rad 5/3. And if you want to move the 1 over, I'm going to move that 1 over. What the heck? I'm going to take it away and move it to the other side. I will then get x equals -1 plus or minus rad 5/3. And you are the most impolite mathematician I have ever met if you leave your answer like that. Polite mathematics. We never leave rads in the bottom, and we always get common denominators for the next person who's coming along. So, what does that mean? Well, let's go back to just this step right here. If I multiplied the bottom and the top by radical 3, I would then have plus or minus rad 15/3. See, we never leave rads in the bottom. So let's see how that looks. -1 plus or minus rad 15/3. But see, here's the deal. This guy right here has a 1 on the bottom. That's his denominator. We're not supposed to do that. We're supposed to get common denominators so that the next dude or dudette does not have to do that. So I'm going to get a common denominator. Multiply top and bottom by 3. Then I would have -3 plus or minus rad 15. Both quantities are divided by 3. That would be the polite answer. Now, those x-intercepts, those are politely written with no rads in the bottom, but be careful. What this means is when I'm going to turn these into decimals, when I'm going to convert these to decimals, I have 2 versions of this. I have -3 plus rad 15/3, that's 1, or I have -3 minus rad 15/3. Here's where you got to be careful with your calculator, because all calculators have the same flaw. I will say this again and again. No matter how smart that graphing calculator is, it only knows how to divide one number by one number at any time in its life. So you would have to put this whole thing in parentheses, if you're going to do that and divide it by 3. If you do not, your calculator will definitely, without a doubt, lie to you and give you the wrong result. So just to prove this point here, this is my last thing. On my calculator, I am going to punch this in, and this first answer, let's see if you guys match up with me, because if you do not, you're going to have trouble trying to figure out why this stuff isn't working. So I'm just going to go out 5 decimal places. That's what I got for an answer when I converted it. So on the homework, I'm just going to say round it to the nearest tenth. So 0.3 is going to be fine. Let's convert this guy. So over here, I'm going to remember that's a -3. That's kind of light. So I'm going to do this on my calculator one more time. So you follow along and then make sure you're punching it in correctly. What I got the second time through here. So this is basically -2.3. All right, so if I was going to sketch a graph, just to remind you, these guys right here, and you're going to hear this a lot, are called exact values. These guys are called exact values. These are decimal approximations. Decimal approximations are great if you're going to plot points on a number line for me, because not many people are walking around with these kind of guys memorized going, you know what, that's really close to -2.3, or, you know, nobody does that. So anyway, what do I want you to do? Let's go back one more time, revisit this whole concept. Pause it, take a picture if you need to. I want you to draw 8 precise graphs. I'm going to give you some of them that start in standard form. I'm going to give some of them that start in vertex form. Find the vertex, y-intercept, and x-intercept, sketch the graph. I did not say anything else in these instructions. It says accurately graph each parabola using any technique you want. Use the easiest method depending on the information presented. List the vertex, x and y intercepts. List any radicals. Okay, so radicals in simplest form. Also decimal form rounded to the nearest tenth. Oh, here's the only thing I did not mention yet. If there are no x-intercepts, write none. One of these will not cross the x-axis, and you will only have 2 points to connect, a vertex and a y-intercept. I leave it to you to figure out which one it is, but if you're curious, you can look at the answer key and find out which one has no x-intercepts pretty quick. 2. 2. Okay. All right, guys. Do your best. Bye-bye.